The Internet of Things, also known as IoT, is generally defined as the technologies that allow connecting things to the Internet and using that connection to provide remote monitoring, management, and actuation of the surrounding environment. The IoT creates a smart and invisible fabric that can be sensed, controlled, and managed. It covers a variety of communication protocols, hardware technologies, and software layers. Conceived as the evolution of the cyber-physical systems, CPS, that leverage the connectivity to the net to reduce the human interaction, represents now a more complex reality where the devices sense, decide, and automatically actuate. This technology infrastructure is built upon the convergence of hardware and software elements that observe the following characteristics. First, smart objects have the ability to communicate and cooperate with the Internet resources and with each other. Therefore, our first requirement is to have a deployment of wireless communication network, while the objects must be capable of sensing and receiving data in that network. The smart object must be located, identified, and addressed in the network. Therefore, all the components of the IoT infrastructure, sensors, actuators, gateways, and even applications that manage the data, must have an ID. First step for registering new components of a network in an IoT platform like TTN, the Things Network, involve to provide such IDs in the web dashboard. The identification of the smart objects must be performed physically by the Diff UI, provided by the manufacturer. During the registering process, the Diff UI is associated with the ID that identifies the smart object in the net, and the App UI, or ID of the application server, this is destination of the messages sent by the nodes. Objects sense the surroundings using a plethora of sensors. This must be selected according to the needs of the application scenario. Objects can also actuate to modify the surroundings. Smart things are aware of their location or can be located either by the manually provided information or the GPS chip included in many of them. In any case, this information can be public or private upon discretion of the configuration. Smart objects should communicate with users in a proper manner. This means that web dashboard will allow the visualization of readings and sensor status. Collected data are stored and processed to develop actuation decisions and provide visualization to users. Requirements of large storage volumes, reliability of the computing environment, and accessibility advise the renting of cloud services as the leading solution. Additionally, specialized cloud providers also facilitate deployment and management web tools that help on IoT solutions. Finally, we can see the IoT as a network of networks. It is a good practice to deploy specific networks for certain applications, mobility, business, energy, and so on, and construct upper layers that perform the convergence of data. This procedure allows different network architectures to coexist and scale the service and coverage up to the whole campus. As a food for thought, IoT as a network of networks where smart objects communicate with each other and with the net. Smart objects must be identified, addressed, and located. User interfaces show acquire information, visualization, and allow registering and management of devices.